Well, class, welcome to our new normal. I actually put makeup on so I wouldn't look so bad on camera. It's definitely interesting times, but we're going to get through this. Please know that I am here for you. I know that none of you signed up for online math, but here we go. This is what we're going to do. So what I'm going to do each week or each day is my office hours will be the same. So if you have questions, we can get on Zoom, or I can just talk to you either email, texting, or over the phone. And one thing I do want to say is I do not check my phone after 9, and that is across the board. Even with my regular online classes, they know that after 9 o'clock I'm done. So I do need to have a time that I am no longer available. So Mondays and Wednesdays I will be here. Same office hours as before. I'm available from 11 till 12:15. That's my office hours. And then, and then also from right after our class, which is 12:30, 1:45, so 1:45 to my next class, which is 3:30. So that's the plan, and we're just gonna be very fluid, be very patient with each other. It looks like I need to adjust my camera a little bit, so give me 1 second. Go this way a little bit. There we go. Okay, so what we're going to do is we're going to start with 11.1. I know you guys are now, most of you are on MyMathLab. If you're having trouble with that, please let me know. What I'm going to do is I'm going to teach the lesson as if we were in class, and then I'm going to give you some little pointers on MyMathLab. So you can print up your homework if you choose to do that. It actually makes it easier, so then you can work through it on paper. As far as your homework goes, it has a due date of our first test, which is, I believe, April 15th on your new schedule. So make sure you take a look at that new schedule. But don't get behind, don't wait. You do have quizzes periodically, and those are to keep you on track. So your first quiz is due March 30th, I believe. And so that is after the first two sections, so 11.1 and 11.2, and then you'll have a quiz on those two. So don't get behind. That's not a good plan, because you do have due dates, and those are going to be hard and fast. So make sure you're keeping up with your schedule. All right, so 11.1 is all about first derivatives and their graphs. This whole section is kind of the epitome of our class. We're going to finish this section, chapter 11, with optimization problems, which is kind of the whole goal of having business calculus, because we're looking for is maximum profit, maximum revenue. So it's a great lead-in. Everything you learn will lead you up to how to do an optimization problem. If you understand each step, then you're going to be fine. So let's just go ahead and get started. So first derivative and the graphs. What we're doing is we're being able to graph a function based on first derivatives, and then we'll jump to second derivatives. So then we're going to put everything together and be able to graph a fairly accurate graph based on first and second derivative. So one thing that you need to be aware of is whenever you have a graph, you have ups and downs. So we're going to keep it simple and kind of keep it within the confines of it has two endpoints. So this is just a small portion of a larger graph. When you have an up, right, this right here would be considered a maximum. Now, there's going to be some terms floating around that you are going to need to know. So one of the terms, let's see if you can see this, one of the terms is the term extrema. And all that means is a maximum or a minimum. That's all it means. You'll see the term relative maxima, relative minima, absolute max, absolute min. We'll get to the absolute part later. All that means is we have endpoints. We have domain restrictions that we're working within. So for instance, if you're in a business and you want to know the maximum profit between months 1 and 6, 1 and 6 would be your endpoints. Okay, so right now we're just dealing with relative extrema. So relative extrema is I can have, more than one maximum, more than one minimum. So if you notice, if we're talking about a maximum, if you notice the slope going into the maximum is a positive slope. So we have an increasing slope here. And then it hits the maximum, which remember your slope goes to 0. That's going to be important. Your slope goes to 0. And then all of a sudden your slope changes from 0 on. When you have a slope of 0, from that point on, it changes. And at a maximum, it changes to a decreasing slope. So we have a decreasing slope over here. So what you want to concentrate on is when you have a maximum, you're going to have a slope, first derivative. Remember, first derivative is just finding slope. So you have a slope that's increasing. It hits your 0, and then it decreases. Okay, so it goes up, and then it goes down. So what we're going to get to is when you have a slope, so this is our first derivative. Here, it's showing an increase. Okay, so I can show increase a couple different ways. You can show it with a plus sign, or I can show it with up arrows, because that is indicating that it is going uphill. And then once I hit this 0, right, a slope of 0, then it decreases. So over on this side, it decreases, or I can use my down arrows. So notice, first thing that I'm doing is I'm indicating that I'm working with first derivative. Okay, so first derivative, what you're finding is where is the slope increasing and decreasing. If it increases and then decreases, you have a maximum here. Okay, that's how you know. It goes up and then it goes down. It makes sense. Over here, I have a minimum. So this is a relative minimum or a relative extrema. It has a point where it switches. So now I have my slope coming into the minimum. My slope is decreasing, just like here. It decreases. Then it flattens out to 0. And then it increases again. So we have an increasing slope on this side. Okay, so if I were to have, this is what we're going to call a test chart, and I do have first derivative. Okay, I have a slope of 0 right here. That's my slope of 0. We have a horizontal line. When we have a decreasing slope, okay, it goes down, and then I hit my 0, and then it switches to increasing. That's when you have a minimum. Okay, it makes sense. It goes down, switches, and goes back up again. So that's a decrease or a minimum aspect of your graph. So with first derivative graphs, what you're looking for is where is the slope increasing and decreasing. That's what you're looking for. Now, if I put values here, let's say this is -5 and this is +5. Here's what I can say. My slope increases, okay, and this is going to go on forever. So it increases, make sure you guys can still see this. It increases from -infinity, okay, so it's coming in, my graph is continuing, from -infinity to -5. And then it also, if I come over here, it also increases from +5 to infinity. So the only places on this graph where I have an increasing slope is from -infinity to -5. And then I jump over here from -5 to infinity. So remember this U, I don't know if you remember this from 1324. This U means union. It's just another term for and. That's all it is. So we have an increasing slope here. We have an increasing slope here. And we're going to show it using interval notation. So remember, interval notation is we have parentheses for infinity. If it doesn't include that point, because right at -5, I have a slope of 0. So it's no longer increasing right at -5. So that's why it's a parenthesis. And then over here, I have a slope of 0 at 5. But from 5 all the way through infinity, I have an increasing slope. Okay, so now let's look at the graph and go, okay, where is it decreasing? So it decreases from here to here. So you can see I have a decreasing slope. My slope is going downhill. So from -5 to 5, it has a decreasing slope. So one thing that you're going to do with your MyMathLab is it's going to ask you, show the intervals. I can actually read it. Here's the question. Find the intervals on which f of x, your function, is increasing, and the intervals which is decreasing, and the local extrema. So here's what it's asking. Where is it increasing? Where is it decreasing? And what's the maximum and minimum? Sometimes you're not going to have both. Sometimes you're only going to have one. But most of the time it's a combination of the two. Okay, so how do you know where your local extrema is? Your local extrema happens where you have an increasing then a decreasing slope. That's your maximum. Or where you have a decreasing and then an increasing slope. That's your minimum. Okay, so how do we do this? How do we set this up when you're given a function? So let me erase this and then we'll start again.